The dynamic model verification is an expensive task. The requirements shall be analyzed. The requirements-based test cases shall be written. The models shall be executed. The modeling errors shall be detected early in the process to minimize the related costs of bug fixing later. In safety-related projects, the IEC 61508 defines a generic software development standard from which all other industry-specific standards were derived. Railway, process industry, machines, gas and measure technologies, medical, and automotive. We will concentrate on ISO 26262. The model architecture and software units shall be developed and verified in compliance with required methods. Dynamic model verification is required for all safety integrity levels. The test-driven development ensures that the software fulfills the specifications and does not contain undesired functionality. Dynamic model verification begins with the definition of verification methods, which is error-prone and very time-consuming. After application of the required verification methods, multiple model modifications will be needed. Requirements-based test cases will be developed and models will be debugged. The software compliance shall then be systematically approved by using the predefined pass and fail criteria. Some deviations from the expected results are acceptable or even necessary for safety-related functions. Such deviations need to be documented. The resulting verification reports shall include sufficient evidence of positive results and full coverage of requirements, structure, and other verification methods. All the verification steps will be repeated after every model modification, so tool automation is a must for dynamic model analysis. The criteria to choose the right tool for dynamic model verification are defined in ISO 26262. You need the answers for the following questions. Is the checker suitable for ASIL projects? Is the documentation provided? Are all required verification methods supported? Is the tool qualification kit with tool classification and validation tests provided? How much does the tool qualification kit cost? How much extra time will you need to spend on compliance documentation? The EverTest software supports all the required criteria out of the box. With no additional fee, EverTest simplifies your tool integration process. Usability can make the difference because test-driven development is a human activity. So the next question shall be how fast you will be while using your test tool and reviewing your results. It quickly becomes an economic factor. To get the usability metrics, we track the user keystrokes, the mouse clicks, and the moves, and the time it takes for the users to move around. We analyze the usability metrics to optimize the workflows, the interfaces, and the reports, and to provide the best user experience on the market today. The required verification methods are well defined in ISO 26262. EverTest supports all the required methods and provides the safety manual where all the methods are explained in detail. The tool qualification kit is provided with EverTest installation. It includes the safety manual and the recommended workflow with related features described in the tool documentation. The tool qualification package provides the tool classification along with the validation tests. EverTest was qualified as a test tool in multiple safety-related projects, including ASIL-D. With EverTest, you can generate the HTML views of your models. Such model views enable offline inspections in any web browser. Only one file is generated, allowing easy configuration control. Even very big models open under 1 second. The test harness can be generated automatically for any existing subsystem. Please use the EverTest context menu over the subsystem and click on Create EverTest Harness. EverTest recognizes the interfaces and inserts and connects the EverTest source and sync blocks. The EverTest user interface and the related test specification file are opened, and you can start the unit testing right away. Please see the EverTest help for more options and API support. At the beginning, just after the test harness generation, the file contains a sample test case and an interface definition. The test specification will be stored in one Excel file, which simplifies reviews, data exchange, and configuration management. The test specification is accessible over the EverTest UI. You can exchange the Excel files in the EverTest UI. You can open the Excel file and jump to the interface definition sheet, and you can navigate to the relevant test case. You can add more test cases and rename those in the EverTest user interface. The test cases can always be edited in the Excel sheet. The time column contains the time steps needed by the simulation. If no input or output changes, it is also possible to skip a time step. The input columns contain all input signals defined on the interface sheet. The values for the time step in the column T can be defined here. If a value does not change from one time step to another, its value can be left blank. Reference signals define the expected output values of the simulation. Similar to input values, the cells can be left blank if the value does not change during a specific time step. Output values can also be ignored by using the question mark. Output signals will be filled with the actual outputs from the last test run. They will be colored in red if they deviate from the related reference value. They get the green color if they are as expected. The time vector inherits the colors based on criticality, red over green. The parameter values are set for the current test run at time step 0. You can change parameters in each test case. If the design ranges for the inputs are defined, you can generate the test case for that input automatically. Please use the context menu for coverage of design ranges and choose the input signal. The new test case will be generated. You can specify the reference values and parameters and run the test case. EverTest measures the coverage of design ranges and gives hints on how to improve it. You can associate the unit requirements with your model elements. EverTest will recognize regular comments in the model as requirement IDs if you use the correct prefixes. You can use the same requirement IDs in the description of the test specification. After EverTest update, the requirement ID will appear in the test case list of the UI. The requirements matrix will be generated with the verification report. EverTest gives hints on how to improve the requirements coverage. EverTest enables visual representation of test case data in the verification report with the EverPlot function. EverPlot generates dynamic signal plots for offline debugging. Such plots are synchronized with the test case data for easy analysis. EverPlot can inline the screenshots of Simulink scopes in the verification report for each test case. Just use the name of the scope in the EverPlot function. The scope will be inserted in the verification report. Static model analysis is the most effective way to avoid design errors. You can run EverCheck or Model Advisor automatically from EverTest. The static analysis report will be generated. EverTest utilizes Simulink coverage for model and C code. EverTest provides quick access to decision and modified condition decision coverage also called MCDC, the measurement results are integrated into the final verification report. In the EverTest step-by-step debugger, you can view blocks, outputs for each block, and at each time step, follow relevant signals on the scopes and viewers, analyze the model coverage of the specific test case at each time step. EverTest supports open-loop simulations of the controllers out of the box. For this, all input signals need to be defined in the test specification. All signals are documented in the final EverTest verification report. EverTest also supports more complex test scenarios. You can define a bypass signal in the interface sheet of the test specification. Just use the IC type instead of I type for the related input. The C stands for closed loop simulation. After update in the EverTest user interface, you will receive a bypass signal for the EverTest source block. Now you can provide an external input signal which will be reused in the test case. The bypass signal will be grayed out and documented in the final EverTest verification report. Such bypass signals also allow the closed-loop simulation with a plant model. Such test scenarios enable reactive testing. It means the controller reacts on the signal provided by the plant, and the plant will be controlled by the controller. Reactive testing allows constructing all possible scenarios and simulate the behavior in virtual prototype. The results are documented in the final EverTest verification report. EverTest allows easy integration of generated or handwritten C code into Simulink models. Please use the context menu of the subsystem and choose Integrate External C code. The external C code will be integrated to run the software-in-the-loop simulations with the existing test cases. You can measure the C code coverage. Both Decision Coverage and MCDC are supported. You can also debug your C code by using the Microsoft Visual Studio. You may also decide to run the processor-in-the-loop simulation with Lauterbach Trace 32 simulator, or you may also run the hard processor-in-the-loop simulation with the appropriate developing board and the hardware debugger. C sources can be used and tested with existing test cases in different environments by using native compilers, profilers, and debuggers. The verification reports are generated as single HTML files. The images are inlined. Here is a static analysis report, the coverage report, and the final verification report with management summary and links to the relevant data, as well as all test cases and plots. You can open these verification reports in any browser, on any machine, anytime. All EverTest features are designed for great usability and full compliance with safety requirements and quality metrics, enabling test-driven development with a lot of pleasure.